Okay, we're back with the next two. So we're on to graphing. Part 6 is graphing. Again, there's a bunch of different ways you can graph. You can plot points. You can use what's called the intercept method. That's pretty easy. You just make a little chart. I guess I'll do it right there. And you say, well, when x is 0, what does y have to be to make that true? Well, y would be a -6. So when x is 0, I've got -6. Then when y is 0, what does x have to be to make that true? Well, 15 times 2 gives me 30. So when y is 0, it's 2. You just go and graph by plotting 0, -6. So when x is 0, I go down 1, 2, 3, 4, 5. There's -6. And then when I go over to 2, 1, 2 for x, that's when y is 0. And there's my intercept method. I could also take this whole thing and put it into slope-intercept form by transforming it, hammering it out into y equals mx plus b form. That's slope-intercept form. And I would do that by subtracting 15x from both sides. And I would get that -5y equals -15x plus 30. And then I would divide everything by -5. And I'd get y then is equal to 3x and then -6. And then this is my intercept. So along the y-axis, I'd go to -6. That's right there. And then that's my slope. It's 3 over an invisible 1. And slope is rise of 3 and a run of 1. So I go up 1, 2, 3, and I go over 1. I could go up 1, 2, 3, and I go over 1, and I'd be at that point. I could keep going up 3 and over 1, and there I'd be. Or I could go back 1 and down 3, but that's still a slope of +3. Okay? A little bit more difficult is if you're given only 2 points and you're asked to come up with the equation of the line that goes through 2 points. This is like really a fundamental skill. So I hope you get it. Practice it on your own. It'll definitely be on the quiz. I need to find the slope, and the slope is considered the rise over the run. And this is all in your review. Change in y over the change in x. Those little symbols there mean the change. Well, the change in the y goes from 6 to 7. That's only a change of +1. I like to use this arrow method because it's very visual, it's very straightforward. Use the second coordinate to begin with because it always goes x, y. Well, the change in the y's is the change in the rise, and it goes from 6 to 7. That's +1 over a change from 2 to 16 is a change of 14. So that is a slope of 1/14. So that's my m, my slope. And then I can just put it into point slope form. And that's going to be y minus either of these y points. I like that one because it's first. Y minus 6 equals the slope, 1/14, then x minus that x coordinate 2. If I want to transform this into slope-intercept form, I can do that quite easily. Y then is equal to 1/14 x minus 2 and then plus 6, and I just distribute this out. Y equals 1/14 x and then minus 1/7, right? 2/14 is 1/7 plus 6, and so my final answer would be y equals 1/14 x and then plus 5 6/7, right? A -1/7 plus 6 is going to leave you with 5 6/7. So there we would go. And on to the next two. Okay, we're on to simplifying radicals. This is one of the stranger problems. There's a bunch that are pretty easy. Look for the straightforward perfect squares. This one requires a little bit of work. What I'd like you to do when you're simplifying radicals is to just start by taking out 2's if it's an even number. Keep doing that. 2 and 90. You can look for perfect squares, and that's sometimes a faster way, but it doesn't work every time, and you can sometimes overlook factors that will simplify it further. Anyway, if you keep going like this, that's an even number, so I take out a 2 and I get 45. 45 is not an even number, so I ask, can I take out a 3? In this case, yes, I can take out a 3. Take out always the smallest possible factor. I get 15. I can still take out a 3, and I get 5. And now these are all prime numbers. Well, once you get this, I try to emphasize that. I circle it, and I get what I call the hockey stick. And when you've got the hockey stick, look for pairs of numbers, because pairs of numbers will produce a perfect square, and you can take them out. 2 times 2 is 4. I can take the square root of 4, and out comes the 2. You always take out just the one number. Here's a pair of 3's. 3 times 3 is 9. Of course, that's a perfect square. I take out the square root of that, and it's 3. It's always just one of these two numbers. What's left behind is the lonely little 5, and that stays under the radical. You do multiply, that's just the way it works, and I get 6 radical 5. So this is simplest radical form, pretty straightforward. Sometimes these can be really long, sometimes they don't work out, they're really short, but that's what you do. But then they also want you to estimate, without a calculator, what is that approximately? Well, you should know your perfect square is up to 12 times 12 is 144, and this is bigger than that. One of the reasons I did it. 13 times 13 is 169, and 14 times 14 is 196. So you can see it comes somewhere between 13 and 14, and you can just say 13.5. That's a good estimate. So if you mistype it in your calculator and you get an answer and it's 30, you kind of know it doesn't make sense, all right? A lot of times your estimation skills will be plenty accurate to give you a decent ballpark figure to check your answer. All right, then we're going to go on to factoring. Now this is often the #1 tough topic, so I'm going to spend a little bit of time on factoring. I'm going to choose maybe one of the more difficult problems. I think I'd like to look at J. J starts out there as, I've got it over here on the side, it's n to the 4th minus 25n squared plus 144. Okay, as you look at these, you try to see if there's a common coefficient that you can take out. In this case, there's none, but if this had been an even number and this had been like a 2, I could have taken out a 2 from everywhere. Also, I try to take out a variable if I can everywhere, and there's some that you can do this, but I cannot here because there's no n there. So then what I'm left doing is I'm asking, well, is this a 2 to 1 ratio? And if that's true, then you can try to factor it, and 4 is twice 2. So there's a chance I can factor this as n squared and n squared, multiplying to make n to the 4th, and then the rainbow check, as I call it, will give you the n squared middle term, and then I need two numbers that multiply to make 144. Well, there are different ways to do this type of factoring. There's a method that's rather systematic that will take a little bit longer but will get you the right answer every time. And I think I'm going to try to show you that real quick just because it's worth knowing. You can also just do it by guess and check, where you list all of these multiples and then you see if you can get this middle term to work out. But the method that works every time sets up something like this, where you simply write the first term and the last term. And I tell you what I'm going to do is, just to make this a little bit simpler, I'm going to translate this to be x to the second power, and then minus 25x, and then plus 144. If I can factor this, then I'll simply replace the x with the n squared and I'll be good. Does that make sense? Hope so. So I write x squared and 144, and then as I multiply I get 144x squared. Just write that same thing over here, 144x squared. And now what I'm looking for is two numbers that multiply to make 144x squared that add up to a negative 25. Well, if this is a positive, the only way that's going to happen is if both of these numbers are negative. So it's going to be a negative and a negative. And I just list factors of 144. Well, I can start with 1 times 144, but that's never going to be an option. But 2 and 72 might. And I can go on down. 144 has a lot of factors. If you list all of them, and again, these all are going to be negative, but once you know you're looking to add them up, you can leave off the negative signs because it can be confusing. But do these two numbers add up to 25? No. But skipping ahead a bit, 9 times 16 does add up to 25, and that does multiply to make 144. So that's where you can use your calculator systematically. Take a little bit of time, but you'll get these numbers every time. Negative 9x, negative 16x. It doesn't matter which one goes where. These multiply to make a positive 144x squared. Now I simply